we tend to find evidence and select evidence that confirms what we already think to be true. We count that as evidence. We really like confirming what we already believe. So this is another, what I find to be a good activity. It doesn't have to be, you don't have to be a physics teacher to do this kind of an activity. If you are a pre-service teacher, I just find this a valuable activity. So most of us have gotten to the point where, in fact, I'm going to go back and I'll share my screen again. So again, here's the sequence 248, and we broke off into little groups. I asked you to create your own sequence, and I told you whether your sequence followed the rule or did not follow the rule. And ideally what you would do is you would do this several times, and then once each group has gotten a chance to try several different sequences, then they can propose what they think is the rule. I tell them whether they've got the rule correct or not. So a couple of groups here said doubling. They proposed 1, 2, 4, or they did 3, 6, 12, or something like that. They said the rule is that you double the first number to get the second number, you double the second number to get the third number. I said that's not the rule. Another group said 3, 9, 27. They gave me 5, 25, 125, which that's clearly not doubling. But it's essentially it's an exponential kind of pattern. You take the first one, you square it, so it's a number to the x, right? 3 to the first power is 3, 3 squared is 9, 3 cubed 27, right? Or 5 to the first power is 5, 5 squared 25, 5 cubed 125. That's the pattern they proposed. That was the rule they proposed. Turns out that's not the rule either. So what's the rule? And I try not to belabor this point where we get to the point of frustration. What if I told you that -1, -2, -4 does not follow the rule? Because that's doubling, isn't it? But it doesn't follow the rule. Or that -5, 25, -125. That doesn't follow the rule either. That would be x to the, or number to the x. That would be an exponential pattern there, but it doesn't follow the rule. So what's the rule? What if I told you that 1, 1, 1 does not follow the rule? But what if I told you that 1, 2, 3 follows the rule? What if I told you that 1 million, 2 million, 4 million follows the rule, and also that 1 million, 1 million and 1, 1 million and 2 follows the rule? What's the rule? Thank you, Sydney. Yes. Is it just increasing the number? You betcha. All it has to be is just ascending numbers. In fact, I guess I could have included, I could have said 1, 1.5, 2, possibly. Because all we have to have is just ascending numbers. Each number has to be bigger than the one before it. That's it. That's the rule. So why the heck did we do this? Why did we, again, burn valuable instructional time on this silly exercise? Because I don't think it's necessarily silly. I think it has a lot of application. Which gave you better, more useful information? When I said yes or when I said no? What you're going to find this semester is that I'm really intrigued with how people form beliefs or ideas. So when you saw that 248, most of it, we're a pattern seeking species. We can't help ourselves. When you saw 248, you immediately were looking for a pattern, partly because I said these numbers follow a rule. And so you looked at those numbers and you used your own knowledge of math and you looked for a pattern. And a lot of you leapt to, oh gosh, well, 4 is just double 2 and 8 is just double 4. The pattern must be doubling. And then what did you do? You proposed sequences of numbers, 3, 6, 12, 4, 8, 16, 16, 32, 64. You proposed sequences of numbers that would give you, if I said yes, that would give you evidence to confirm what you already thought to be true. You already thought that doubling was the rule, and so you created other evidence that followed that same rule to confirm then what you already thought to be true. And human beings are really good at this, especially in social media. We tend to find evidence and select evidence that confirms what we already think to be true. We count that as evidence. We really like confirming what we already believe. And my question for you is, did it do you any good? I said, okay, 2, 4, 8. Now you guys come up with a sequence. And you said 3, 6, 12. And I came along and I said, that follows the rule. Did that help you at all? No, I don't think so. Because then you're like, well, yeah, we got the type 6, 12, 24. And I said, yeah, that follows the rule. And you thought, hey, we got this. Pat on the back. When in reality, you were actually confirming your own belief in an idea that actually was not the rule. And I find that really interesting. We have this natural instinct to want to confirm, when in reality, disconfirming is actually more valuable. When I said -1, -2, -4 does not follow the rule, that actually gives you some useful information. You're like, well, gosh, well then doubling can't be, because -2 is double -1, and -4 is double -2. And yet he's telling me that that doesn't follow the rule, so doubling can't be the rule. And that helps me. That's very beneficial. So it turns out, and you'll read about in the first chapter of the book, or like I said, any science textbook is going to start out with a discussion of the scientific method. And an important part of the scientific method is that you've got to be able to falsify. Whatever your hypothesis is, there's got to be a way of determining that that hypothesis could be wrong. It doesn't mean that your hypothesis is wrong, but there's got to be a way of knowing whether it's right or whether it's wrong. It's got to be falsifiable. And that's really important. And I encourage you, especially like I said, in social media, it's so tempting to want to, there's something that hits you and you want to fire off a belief, or you want to share something that you believe in, that you think the rest of the world needs to know about. I want you to first ask yourself, how could that belief be wrong? And maybe that will give you pause. And maybe you won't share it at all. Because if you really think about it, you think, gosh, how could I be wrong about this? That might give you a better insight as to the true confidence. Why are you so confident? Are you so confident because you've specially selected evidence to back up something you already think to be true? Have you really tried to falsify your position? If you have done, if you stress tested your idea, if you've actually sought out ways that you could be wrong, then you're more likely to be right. But if you've not done that, hey, step away from the keyboard. If I happen to be mistaken, this is essentially a way of saying, this is falsification. If I happen to be mistaken, do I have a way of determining that? Is there something I could learn or find out that would make me change my mind on this issue? if I don't have that, I possibly could be believing something that isn't actually true. And I don't think any of us want to be in that position, because the belief that we're holding doesn't really have any value in that case. These are issues that I will return to, because it's something I'm fascinated with. It applies in science, but it applies in our lives as well.